A pleasant day to all of you. We are from Group 3 of Industrial Laboratory. Today we'll perform the UJT and SCR relaxation and sinusoidal oscillators. Though the UJT and the SCR are commonly used in power control circuits, they can also be advantageously employed in designing simple relaxation and sinusoidal oscillators using a minimum parts count for a discrete oscillator circuit. Such designs are particularly useful in telephone tone generator applications where multiple sine wave audio signals are needed for simultaneous touch tone frequencies.
So we are considering figure 1 here. So initially the UGT is off, the circuit is off, and then when you turn off the circuit, um, VB begins to charge through R. So this the one, this the capacitor is charging through R because of R, and when the VO is exceeds the the peak voltage, the UGT fires very quickly and discharging through the emitter. Okay, so this is where the in theory the the internal resistance of the UJT becomes very low, and then it discharges through here, and it produces an output right here, and then it follows the discharging of the capacitor, and then after the discharge time, provided the current flow flowing through the resistor is less than the valley current, it then switches to high impedance again. The impedance of the resistor will become high again, and then the process repeats after another cycle of the charging of the capacitor. So we're going to test each output waveform of the following pin junctions: the E, the B2, and the B1. So we'll start first at the E. After this is the charging of the capacitor, and okay, that is the charging of the capacitor. So this is time it takes to charge the capacitor, and the discharging time is T2. Yan na yun. Okay, so the output of this circuit should be like this. At the time when the capacitor is still charging, the output should still be zero, and then after it reaches its peak voltage, it discharges through the output, then discharges, and then it follows the another cycle, and then so this is the output we have on our circuit. Yeah, hindi ko alam. So this is the output we gathered from our circuit, looks like this from at pin B2. Yan. Pakita mo na lang. Yan. So there it is, our circuit number 1. Okay everyone, so this is our figure 2, which is composed of still UJT, but we added some modifications, and we added a inductor, and the resistor that is controlled by charging the capacitor is replaced by a potentiometer. Here, this one, and then the output that we have to obtain is a sawtooth. So this is the output. Okay, show them. Okay, so this is the output from figure 2, the modified circuit. Yes. Okay, so this is the other operation of UJT, which is a negative resistance used to cancel out the physical resistance of the coil. So after constructing the circuit, um, the output at the 100 ohms looks like this. Yan. Play. And this is the waveform we got at the emitter of the UJT. Okay. And this is the waveform of B2. Hello everyone, and this is the presentation for figure 7 using an SCR with an operation of improved circuits for oscillation generation. So this is the actual circuit we constructed, and as you can see, there's a speaker output. So you probably won't hear the output of this circuit when our mic is so far away from the output. So I'm going to let you hear the output of the speaker. Okay. Sige. So after letting you hear the output of the speaker, we're going to show you the output waveform of our anode of the SCR. And here it is. The out, at the pin anode. Okay. And this is the waveform um, at the gate of the SCR, and at the cathode it shows nothing, zero, because the oscilloscope is short at shorted configuration. Yun.
Circuit of our figure 6, and this one here is the circuit that we made. Now this waveform came from the gate terminal. Now this is the waveform on the anode terminal. As we can see a while ago, the waveform of the anode is much larger or greater than the waveform in the gate.